So, good morning, everyone, and good morning, madam.
Good morning.
So, all the participants today, first, I am introducing today's expert. Her name is Dr. Dharmistha Vishwakarma. She is currently working as a lecturer at Department of Electrical Engineering and IT, Polytechnic, the Maharaja Sayajirao University of Baroda. And she also worked as an assistant director of Computer Engineering Department in Polytechnic. She has completed her PhD in the field of wireless ad hoc network in the year of 2012 from the Maharaja Sayajirao University of Baroda. She has received Sir Thomas World Memorable Prize in year 2009 for the best publication of the year. She has published and presented more than 30 papers in the various journals, national, international conferences, and she has also received grant for the minor projects from the various funding agencies. And she is talking on the topic today's energy management system in future grid. So welcome Dr. Dharmishta Vishwakarma madam. Now you can start your session. Hello madam.
Hello.
Yes ma'am, now you can start your session.
Yeah. Am I audible? Am I
Yes,
audible?
Yes,
yes, yes.
yes ma'am.
Yes. Yes. Okay. Thank you so much, Sheetal ma'am, for inviting me and the dignitaries who are present over here and giving me this opportunity to present something or to give some knowledge or overview to the students regarding the topic. So today's topic is the energy management systems in future grid. Okay. So here today we will be going to learn. I can say learn because I am not giving any extra. You can say the lecture. Actually, we will be discussing something regarding the topic. So definitely, I hope you will be learn something from this, and it will be useful to the students as well as who are attending over here. Okay, so let me start the further on this topic. So here we are having energy management systems in the future grid. So nowadays, whenever we are talking about the world, everything is digitized. So this this digitization, this digitization is the you can say one of the key factor which is nowadays utilized to going to implement or to upgrade the systems. Okay, because digital thing is having a very good efficiency. I can say it is having a data rate faster. So digital things are nowadays becomes popular because of its advantages. Okay, so the world has gone digital nowadays in the electrical industry also, and it is now necessary to include the digitization in the electrical systems. And as per the you can say the survey, it has been noticed that the right now India is one of the country which is utilize energy more than the other countries. So it stay at the fourth position in the world, and it is forecasted by the International Energy Agency in a short term that India will overtake the position from fourth to the third position. It means the because of the increasing the population, because of the urbanization, industrialization, that will basically consume the energy more and more in next 2 decades. Okay, so due to this increase in the energy demand, we definitely have to do something for the electrical system. So in this world, where when we are having the more energy demand that rises, then definitely it will be problematic or it will be threatened to the existing electrical system, that how to satisfy the electrical demand by the consumers. Okay, so to improve that, the system or to cope up with the energy demand. Basically, we require to upgrade the system, or we have to do something such that within that energy only we can perform or we can satisfy the energy demand. Okay, so here the main aim of the you can say energy management system is to reduce the peak demand, which is during the peak hours generally occur, because during the peak hours it might happen the system will not be able to give the energy to all the consumers, and due to the high rise in the demand it might happen the system will get fail. Okay, so to discuss these things we have to go for the some techniques which will be upgrade to the existing grid, and that will known as the future grid. And we have to discuss something regarding some energy management techniques or the systems which will be generally utilized for this future grid. Okay, so here in this presentation we will be going to cover the introduction, electric grid, future grid, what is energy management, why it is required, dynamic energy management, microgrid, then the challenges in the future grid. Okay, so these things are to be covered in this presentation. So as we have discussed that day-to-day life that raise the power demand because of the, you can say, the population increases, because of the industries increases, because of the growth of the you can say demands. Okay, so we are having a very much requirement that we have to do something for the energy so that the demand gets satisfied by the existing grid, or we can upgrade the existing grid so that it will satisfy the demand during the peak hours. That is more important. Okay, so whenever we say in the day-to-day life to resolve this issue, to satisfy the demand, peak demand, or to satisfy the demand from the consumer, then we are having two solutions. Okay, so to resolve this issue, the electrical utility and the system operator having the two choices available. The very first choice is to, we are having one simple choice that if the demand increases, then definitely we have to increase the size of, you can say, electrical system, or the system from where the electricity generated, that we need to increase. Okay, but this is not feasible generally. Okay, why not feasible? Because day to day whenever the demand increases, and according to that if we implement or increase the size of power system, or you can say power station, or electrical system which generates the energy, that is not that much cheaper, it is very much costlier. So it is not easily expandable, the existing grid or existing electrical system. So the very frequent, you can say, the increase in the size in the electrical system, it is not feasible solution. So definitely we have to go for second solution. The second solution is to utilize the energy management in order to reduce the possibility of high peak demand during the peak hours. It means we have to do some techniques, we have to apply some algorithm, we have to give some method through which we try to not increase the energy demand beyond some limit. Okay, so that is, we try to reduce the high peak demand during the peak hours. So this is our try. Okay, so whenever there is the demand that more power plays, then definitely we have to go for the option that is energy management. Okay, so the energy management why actually require, because whenever we are going for the uh, any electrical system, the energy is not that much cheaper that we can waste it. Okay, definitely energy cannot be generated, it cannot be, you can say, destroyed, but definitely we can convert any form of energy into another form. Okay, so definitely we do not have to waste the energy, so we have to save the energy so that the consumption will be less, and the energy which is utilized, it is ultimately beneficial to the nation. Okay, so energy management should be done such that it will be beneficial to the economic of the nation. So energy management can be considered that is a must parameter for the electrical grid or electrical system by some various reasons. So what are that reasons? The reasons are that it helps to the electrical system to optimize the functionality, and it will beneficial to the generation units as well as to reduce the generation cost. Okay, one more reason that it helps the system operator to reduce the energy loss by doing the energy management in the networks and in the transmission lines. Okay, and due to that it will affect to the electricity cost. It will help to the end user to manage the load such that the electricity bill can be reduced. It increases the load factor. It will definitely affect to the energy efficiency, and it will conserve the resources. So let us first look at the electrical system through which we can we are getting the energy. Okay, so we are getting the energy from the system. It is known as electrical grid or electric grid. Okay, so what is grid? Grid is represents the term which is known as network. Okay, so the network of the transmission line, substations, transformers, and more that deliver the electricity from power plant to the consumer, this is known as electric grid. Okay, so ultimately we can say it is the system which will provide the electricity from the generation side to the individual customer. This system is known as electricity grid, and it is generally referred to a way to transmit and distribute the electricity. Okay, so the electricity grid delivers electricity from the generation point to the consumers in a two primary way. One is, or you can say, the transmission system, and another is known as distribution system. Okay, so transmission system, that is from power plant to the distribution system substation, and the distribution system will be from distribution substation to the consumer. So this is the way your electric grid is divided into two network, transmission system and the distribution system. So now let us go further for the structure of electrical grid, so we can understand what is meant by transmission system and what is meant by distribution system. So to study the future grid, definitely we have to learn something regarding the basic electrical grid, how it forms. Okay, so the basic components of the electrical grid, that generally starts from the generator. Okay, so generator will generate, it is having some resources that can be based on the, you can say, conventional energy. So in the traditional grid, I can say it is generally fossil fuel based, you can say, the generators are available. So generator, it is a device which converts the mechanical energy into the electrical energy. Okay, and this will be the mechanical energy can be in the form of, you can say, generated through the steam turbine, gas turbine, water turbine, internal combustion engine, wind turbine. So all these are the sources of mechanical energy, and these can be converted into electrical. Okay, so once the electricity is generated, it can be transmitted through the transmission line. So transmission line basically transport the electricity from place to place, and in this, the transmission line generally transfer the electricity in the bulk movement. So the very high amount of electricity will be generated over here. Just a minute. Okay, sorry. So the transmission line, it is generally to transmit the electricity from the generating station to the substation. Okay, So now what is mean by substation? The substation is basically different functions that performs. Generally, it will transform the voltage from low to high or high to low based on the step up or step down requirement for the distribution system. Okay. So the next component of the electrical grid is the transformers. The transformer, as you know that you are from electrical engineering branch, so definitely you should know the transformer function. It basically convert, you can say, low voltage to high voltage or high to low without change in the frequency. Okay. Next is distribution system. This is the final stage of the electrical grid. Basically, it is distribute the energy to the various stakeholders like homes, industries, and all other users. Okay, so it delivers the electrical power to the every user on the grid available. That is the response of the distribution system. So now further, let us go for the why we know go for the modernization of the electrical grid. Okay, so definitely we have discussed that nowadays digitization is the part of every system, so it also should be the part of electrical grid. Okay, but this is not only the reason that everybody is going for digitization, then the electrical system also to be digitized. It is not the reason. The main reason behind this is that the existing electricity grid, actually it is unidirectional in the nature, that from the generating station to the consumer the electricity comes, but consumer cannot give the electricity to the grid. Okay, so this is known as one way, you can say, transmission that is existing in the electrical grid. So, and another reason that it is fossil fuel based the electricity system, which basically convert 1/3 of the primary fuel energy into the electricity without recovering the waste heat. So ultimately we can say whenever we are using the fossil fuel based generators, almost 8% of the output is lost along the transmission line, while 20% of the generation capacity exists in the line, and that will satisfy the peak demand only. Okay, so in addition to that, because of the hierarchical topology, the existing electrical grid generally suffers from the domino effect failure. It means suppose some one you can say station get failed, then further all the connections will get the outage of the power. Okay, so that will be having the domino effect. So to avoid this system failure, the amount of power which is generally to be flow in the transmission line, it must be below the line's capacity. Okay, so we cannot go for the maximum limit that 100% power is available and 100% demand is available. That is not possible. Always we have to keep the demand that is less than the capacity of the transmission line. And if we exceed the capacity beyond the limit, then definitely the heat will be generated on that line, which will definitely cause the failure of the system, or it will create the instability in the system, or it will go for the phase or voltage fluctuation. And this is definitely not to bear by the consumer. Okay, so even we are having the various types of renewable energy sources are available to give the energy to the consumer, but it is not easily integrate with the existing grid, because the renewable energy sources are giving the fluctuating output to the grid. So that is not easily to integrate the renewable sources into the grid, existing grid. So definitely we need to modernize the grid, as we require some, you can say, improvement in the grid, existing grid. Okay, so if we modernize the grid, then definitely it will be future for the system, Okay, so whenever we modernize the grid, and if we say the future grid, then what will be the, you can say, the system which is having the facility. So whenever we want some modernization in the existing grid, then definitely our system should be having ICT based, or it can be having the combination of the information technology, automation, communication technology with the electrical power system. Okay, so whenever we are having the upgradation in the existing grid, then it should be having the facility, or you can say it should give the outages that generally occurs in the villages, that should be reduced if we upgrade the system. It must be reduced the storm impact, it must restore the service faster if the outages occur. Okay, so these are should be features of the future grid. So we require upgradation in the system according to this requirement. And if we upgrade the system, the consumer should manage their own energy consumption such that the energy consumption can be reduced and the cost also can be reduced. So utility also should get the benefit from the modernization of the grid. It should include the security. It should be having the feature of reducing peak load. It will be having the integration of the renewable sources, and definitely it must reduce the operational cost in the future grid. Okay, so we need the electrical grid which allows all this facility with the energy management in the real time between the grid and the customers. Okay, so next generation electricity grid should be having the facility as it is listed over here, that it should be with the automation, uh, improved the communication technology, information technology. All these things should be integrated in the existing grid, and it can be having the capacity to do the two-way communication between the generation and the consumer. So the consumer can also utilize the energy based on the cost, that I have to reduce the electricity bill, and that information can be received by the consumer in the real time, and that will give the meaning to the future grid in the sense of smart grid, or we can say it can be intelligent grid or microgrid, nanogrid. These are the various terms generally utilized for the future grid. Okay, so basically the smart grid is the main concept which will be having all these facilities of the information technology, automation, communication technology integrated with the electrical power system. So it will basically allows the consumers to interact with the grid, that is in the two-way communication. So ultimately, the future grid is the combination of the electrical infrastructure and information infrastructure. Okay, so now we are going for the structure of the smart grid, or we can say the future grid. Okay, so what should be the structure? So in this structure, you can see here the lines between each and every unit. We are having different units, that is generation unit, transmission and distribution unit, residential, customers, commercials and the industrial. All are exchanging the electricity with the power network, that is dark line, and this dash line represents the telecommunication. It means in the real time we can exchange the information between all these units. So we are having basically the generation unit, which is not only the fossil fuel based or the conventional energy based, but it is having some renewable energy generation also. Okay, then we are having the transmission and the distribution, which is having the grid automation with the intelligent substation and the smart switching, distribution with the capability for remote monitoring, as well as the control system for the area, wide area to be covered by the transmission and the distribution. We are having the end users like the residential, or you can say the consumers with the smart home. We are having the industrializations with the smart buildings, with the energy storage systems, with some distributed energy system. So distributed energy system means it is having some local generators, that is generated through the renewable energy sources like solar, wind, hydro. So all these also can be generated at the you can say near to the consumers. Okay, so that type of facility is available in the commercial and the industrial area. Okay, so this is ultimately the structure of the smart grid, and all these consumers or the end users can read their consumption. They can know their consumption, that how much energy get consumed and how much energy to be consumed, so that I can reduce my electricity bill. Okay, so this way the real time communication generally occur in the smart grid with the consumers and the generation unit, or with the grid. Okay, so this is the structure of the smart grid. So whenever we say the two-way communication, then it is smart grid. It is not like that. So what actually makes the grid smart? Only two-way communication is not the smartness in the smart grid. So what is the smartness available in the grid, so that it is known as smart grid? Okay, so smart grid will basically consist of the controls, computers, automation, new technologies, and the appliances, which basically all these work together so that the information can be exchanged in the real time, and the grid can behave based on the demand, and the consumer can behave based on the requirement or based on the available energy. Okay, so basically these technologies will work with the electrical grid and respond digitally to the quickly changing electrical demand. And the smart grid includes the integrated sensor based systems. It improves the grid operation, it improves the energy distribution, monitoring, controlling of the alternative energy sources to increase the production efficiency or to generate generation efficiency. Okay, so smart grid technology basically includes the advanced equipment, advanced sensors, then phase measurement unit, which will basically allow to monitor the consumers, and the consumers can monitor the available energy, and this is the way one can do the two-way communication to do the energy management or to reduce the energy cost. So smart grid is ultimately the combination of traditional distribution network with the two-way communication network, and it is having sensors, monitoring appliances, then dispersion of the information in the real time. And all this facility makes it the smart. Okay, so what are the basics component of the smart grid? It is basically definitely hardware is available with some intelligent appliances at the consumer side, sensors, embedded processors, which will monitor the energy available, and it will react on that. Okay, and from these smart appliances the grid will be able to take the information that how much energy is right now consumed by the consumers. In the software side, if we go, it can be done through the SCADA system, energy management system, some another vector processor. Some softwares can be utilized with the smart appliances to do the two-way communication. Okay, so we are having to exchange the information. The third, you can say, component, it is communication. This communication can be wired or wireless communication. If we go for wired, then definitely optical fiber and all other, you can say, for wide area network, then home area network. This type of networking facilities also available in the communication for the wireless. And using high speed, high bandwidth, we can exchange the information between consumer to the grid or from grid to the consumer. Okay, so smart grid communication basically cover a particular area, a wider area, and it should be able to communicate the real-time information for the energy consumption. So here, whenever we are going from the going for the smart communication, then the devices or the intelligent appliances, sensors, embedded processor, which basically should use the Wi-Fi or Zigbee based on the appliances, so that we can remotely control the particular equipment. We can remotely get the information, and this type of hardware and the communication system should be communicate with each other, so that the system can work efficiently to save the energy or to reduce the cost or to reduce the power consumption. Definitely, the smart grid will be having the substation with some smartness, that is, it is having the monitoring equipment or the control equipment, critical, non-critical operation based on the reaction type of equipment. It should monitor the power station, power status, power factor performance, breaker, security, transformer status, etc. to be controlled by the smart substation. So smart substations use the transform voltage several times in the many locations, that providing safe and reliable delivery of energy. So this is the responsibility of the smart substation. So smart substations are also necessary for splitting the path of electricity in the many directions, and this require large and very expensive equipment that includes the transformers, switches, capacitor banks, circuit breakers, network protector relays, and all other devices. So this type of integration can be done in the smart station to deliver the power efficiently. Distributed generation. So distributed generation is basically having the you can say various types of transformers to step down the, you can say, voltage. It is having some switches so that the particular, you can say, sources, that is renewable sources, can be integrated with the grid, or whenever it is not power available from the renewable sources, we can disconnect that sources. So this type of, you can say, the components basically required in the smart grid. So now let us go basically the three advanced, you can say, the technology basically used in the smart grid to exchange the information or to get the information in the real time. Okay, so basically whenever we are going for the smart grid, it will be having three technology. One is advanced meter infrastructure, second is integrated communication system, and the third is distributed generations. So these three technologies plays main role in the smart grid. Okay, so here we are having the advanced meter infrastructure. So in the advanced meter infrastructure, we are having the smart meters that is generally utilized in this smart grid. So if we look at the right now in the electricity meter, then we are having mechanical meter, which is generally waiting for the technician to read the reading, and then he or she will give the electricity bill after the end of month. So this type of things will not be in the advanced meter infrastructure. So in the advanced meter infrastructure, we are having not to use the technician, but it will use the real-time monitoring capability for the electrical load reading remotely for all the consumers. Okay, so the information on the power usage can be collected periodically after, you can say, 5 minutes or 15 minutes or 10 minutes. At a particular interval, the data will be read automatically by these smart meters, and they collect the data, and they will communicate this data to the grid through the wired or the wireless communication, and it will be done back and forth. The data can be done frequently. So the utility will analyze the consumer energy consumption data, and it will provide the outage information or the notification and the billing information to the consumers. Okay, so smart meters provide the smart grid interface between the consumers and the energy providers. So installed in the place where the traditional meter is there, mechanical meter is there, here itself we can install this advanced meter infrastructure. This meter will operate digitally. It will be having some display which provides some information. It will deliver the signal to the energy provider, and it will help to reduce the energy cost. So smart meter also provide the utilities with the great information that how much energy is right now consumed by the consumers, and based on that it can control the electric grid. So one, we can say the positive factor in the smart grid technology is that the individual can monitor their energy consumption and they can manage their electricity usage by checking the smart meters. Okay, so smart meter basically utilize the real-time monitoring with the display so that the consumer can know how much electricity is used and when it is less expensive to use. Okay, so this way some technology or something or some method can be applied to reduce the cost of electricity, to reduce the energy consumption. Okay, so this is the way the advanced meter infrastructure is basically beneficial. It is one of the important part of the smart grid. The next is distributed generation. The distributed generation is basically having, or it is the system where we are having the various types of energy sources integrated together. Okay, so that is known as distributed generation. So distributed generation, it is having majorly the part of distributed generation is the renewable sources. So in this we can use the wind, solar, biomass. So these are the various, you can say, renewable energy sources which can integrate in the existing grid so that the additional, or you can say the load can be satisfied by this. But suppose the energy is not coming because of, you can say, the cloudy season, or because of no wind in the you can say environment. So at that time we can use the grid instead of this distributed generation. So this is one of the option that we can satisfy energy from the renewable energy sources through the distributed generations. Okay, so this is the way distributed generation is also one of the important to integrate, to use more regarding the renewable sources. Now let us go for the integrated communication system. So integrated communication system, we have already discussed that it can be having the wired or the wireless communication to exchange the information from the consumer to the grid or from grid to the consumers. Okay, so it can use the fiber optics or it can go for the wireless networking. Various types of networking are available, that is the mesh network. At the utility side, we can go for the SCADA, data acquisition systems. Then we can use the various networking protocols like ZigBee, Wi-Fi, Bluetooth, infrared. All these things are available in the integrated communication system. Nowadays, the communication is more powerful. So all the types of communication possibility in the grid can be implemented in the smart grid. Okay, so ultimately what we can say, nowadays we are using internet. Now everybody is using internet in this COVID situation. Everybody is at home. Okay, so in this situation nobody can like to go outside. Okay, so here generally the work from home, for that we require internet. The same way in the future for electricity also the internet will be utilized, and through that we can get the information, we can control the particular equipment, particular appliance from the remote place. And this is the way we can conserve the energy, we can save the energy, we can reduce the electricity bill based on our energy consumption reduction. Okay, so if we have the information regarding that how much energy you have used and how much you want to use further, based on that you can calculate the costing of the energy and you can control the usage of energy. Okay, so this is the way the communication and the smart, you can say, the appliances will be useful to do the two-way communication. Now, in general, let me give one example that suppose we are having a mobile. So nowadays we are in the mobile, we are having recharge. Okay, so based on recharge, that this much balance I have and I have to make this many calls. So we can manage the making a call based on the balance available in our mobile. Okay, so this is the way in the future electricity will be also like the recharge. We can recharge a particular amount and we can use electricity according to that. So this type of facilities will be available if we can having the better communication system that should be integrated with the existing grid. Okay, so this is the way we are having the smart grid. So it can contribute to the nation, that in the economic, definitely the energy costing can be reduced if we have the information regarding the consumption of the energy in our home or at any other place. Okay, and definitely we are having some mobile based, you can say, the electricity, that this much I want to recharge, this much I want to buy, or if we are having the information regarding that, then definitely whenever we are using any information to be exchanged, it must be having some security. So that security definitely will be given by this smart grid. Renewable energy sources also can be integrated through the distributed generation in the smart grid. So most of the you can say load can be satisfied through the renewable energy if possible, and if it is not possible, then we can go for the grid. Okay, so smart grid having the potential to help in the saving the money by helping the management of the electricity usage. So we can choose a particular time where we can get the electricity which is having the low cost. Okay, so it is not like that we are having electricity available, but right now suppose peak load is available, then the costing will be more. But whenever the peak load is not there, the electricity cost will be less and we can use the energy based on our based time, and we can reduce the consumption as well as the costing of electricity. So smart grid able to contribute to the environmental wise, the decarbonization of the energy sources. It will be improve the efficiency in the conversion process and the end uses, and definitely it will give the clean transportation. So smart grid advantages are like it is more efficient transmission of the electricity. It will be having the quicker restoration of the electricity after the power disturbance or the outage occur. It reduces the operation and the management cost for the utility as well as for the power cost for the consumers. It reduces the peak demand based on the real-time information, which will help to lower the electricity rate. It increased the integration of the large-scale renewable energy sources, which can be integrated to satisfy the load according to the energy available from these renewable energy sources. Better integration of the customer owner power generation system, including the renewable energy system. And definitely it will improve the security of the system also, as we are including the number of digitization methods and the smart appliances. So definitely security should be there. So this type of advantages will be available in the smart grid. Okay. So now we have discussed regarding the future grid, that is smart grid. And now let us go for the energy management systems in the smart grid, or how to do the energy management. Okay. So actually what is energy management? It is the planning or the operation of the energy production through the power plant and the energy consumption unit. So definitely we have to apply some algorithm, some method, some plan, so that the energy consumption can be reduced and ultimately the costing of energy can be reduced, which definitely increase the efficiency of the electrical system. Okay, so this is the way. It is not like the energy management means we have to save energy only. We have to save the energy so that the customer will be not disturbed. It will be having the ease of use of the energy with the management of the energy, so that we can say it is the sufficient energy management can be done. Okay, so energy management system, it is a system for the electric utility grid to monitor, control and to optimize the performance of the generation and the transmission system. It is mainly related with the energy saving, so that the public or organization or home can be use it with the in the reduced energy consumption. Okay, so smart energy management system addresses the various ways in which the energy utilization can be made efficient, and in turn it will result in the energy saving. It will result in the energy costing, that is reduction in the cost. Okay, so this is the way we have to do the energy management, which reduces the cost for the energy building and the facilitate without compromising the work process. So that is known as energy management. And especially the availability of the service life of the equipment and ease of use should be remain same in the energy management. Okay, so ultimately the energy management is the, according to, we can say, the ISO 50001, the energy management system specifies the basic requirement to establish, to implement, to maintain or to improve the energy management system, which basically having the purpose of the continuous improvement in the energy performance, in the energy efficiency, energy security, energy use, energy consumption, energy costing. So all these are the various parameters which will combine in the energy management. Okay, so to do this excess or shortage in the energy generation or the consumption of the power, it may perturb the network, or it will create the severe problem in the grid. So it will, you can say, turn towards the blackouts. Okay, so this type of condition can be avoided if we apply some energy management in the smart grid. So basically energy management will increase the balance between the supply and the demand in the efficient way and try to reduce the peak load during unexpected period, and this is the way energy management can be utilized. Okay, so now let us go for the energy management advantages. We can say how it will be available in the smart grid. So it will try to reduce the cost of operation, it will try to reduce the consumption, energy consumption, and definitely energy loss can be reduced, and it will increase the reliability of the network. When we can say the system is reliable, that whenever some fault or something occur, then also the consumer will get the benefit of the electricity, then it is known as the reliable network. So this reliability can be increased if we go for energy management. So we are having energy management systems basically in two categories. One is known as supplier side energy management system, and another is known as consumer side energy management system. Okay, so whenever we can say the supplier side energy management system, then the supplier can turn on or off the generators or the power producer equipment based on the requirement. Okay, so the on-side supplier such as electricity utility, in which some generators are turned on or off to follow the fluctuation of the load demand, and based on that the utilities can be do the energy management. The second category, it is the consumer's viewpoint. We can say the consumer side, it is called generally the demand side management. So demand side management, in which the consumer manage their energy consumption in order to meet the available power from the generation side. So consumer can manage their load as per the energy available. Okay, so the main goal of this energy management is to reduce the cost of operation, consumption, reduce the energy losses, and increase the reliability of the network. So energy management has the very, you can say, it is not limited up to that only to manage the energy, but it will be beneficial to the various factors. So use of energy management ultimately to minimize the electricity bill and the schedule the load demand in the efficient way, so that the peak hours will not occur or peak demand will not be achieved to the maximum limit. So this can be done through this, you can say, energy management at the customer side. So customer side, we can include the householders, residentials, commercial buildings, industries, faculties, all these things we can include in the end user. Okay. So the energy management basically, if we go for the consumer point of view, then we are having energy management in the form of dynamic management, demand response, distributed energy resource programs. All these can be participate in the energy management. These are the algorithms through which we can manage the load of the consumers, and ultimately directly or indirectly it will affect to the performance of the system in the consumption of the energy, in the cost of energy, and this is ultimately, we can say, one type of energy management system. And if we combine all these three together, then it is known as dynamic energy management. So dynamic energy management is a new approach which manage the load at the demand side of the, you can say, in the grid. Okay, so it incorporate the conventional energy use management principle that is present in the demand side management, demand response, distributed energy resource program, and merges them in one integrated framework, and simultaneously it will give the advantages of permanent energy saving, permanent demand reduction, and the temporary peak load reduction using dynamic energy management. So this is possible through the system, which basically consists of the smart end uses devices, distributed energy sources, highly advanced control and communication capabilities, and which will enable dynamic management of the system. And in this dynamic energy management framework, it basically having this practice, so that the higher and more sustainable magnitude or of the improved efficiency can be done both at the customer side as well as utility grid side. Okay, so basically whenever we are going for energy efficient devices, controls, demand response strategies, so distributed energy resource programs, all these things are combined together in the dynamic energy management framework, and this is basically ultimately gives the energy management. So what is demand side management? What is demand response, distributed energy resource program? Let us go for some overview of this. So demand side management is basically tries to equalize the energy consumption level over the day, throughout the day. Demand response basically utilized to manipulate the demand of the customer during the peak load, that how to perform the load consumption such that the peak hours can be reduced. And the distributed energy resource program basically having the renewable and non-renewable sources, so that the particular energy consumption will be done through these renewable sources only. Okay, so now let us go some brief of this demand side management. So it is basically a system or the method in which the customers are encouraged to use less energy during the peak hours, during the day, so that the peak will not be occur, peak demand will not occur. So it will encourage the customer. Just a minute. Hello. Okay, so we are having the customer that encourage to reduce their demand during the peak hours. So that is known as demand side management. So DSM strategies are generally including the load shifting like this. During the peak hours, we can shift our load to another, you can say, time. Okay, so that is load shifting. Valley filling, that here we are not using any equipment, then it can be used over here. We can try to flatten this curve, that is known as demand side management strategies. So we are having these various strategies available over here. Okay, so demand response, basically, as I told you, during the peak hours, how to shift the load so that the peak demand will not occur. That is known as demand response program. Okay, so it is having the concept of load shifting, efficient utilization of energy storage system. So these things can be covered under the demand response. Distributed energy resource program, basically we have discussed this. We are having renewable sources can be integrated to satisfy the load demand, and so that the peak hours will not be occur, peak demand will not be occur. So one more concept in the future grid, that is microgrid. Actually, this is the small size of smart grid. So that is known as microgrid. This is basically utilize the distributed energy sources at the consumer side, that we can install the renewable energy sources at our site, at our home, to reduce the energy consumption from the grid. So most of the energy will be covered through the renewable sources, and if some power required, then we can access power that can be done through the grid. So microgrid can be work in island mode or grid connected. So if the energy satisfied from the renewable sources, then we doesn't require any energy from the grid. It is known as island mode. And if we take some energy from the grid, it is known as grid connected mode. Okay, so these are the basic components of the microgrid, where we are having the distributed generation, load, energy storage system. In the microgrid, we can save the energy from the renewable energy sources to some storage system. So in the peak hours, we can use from that storage system. Okay, and through the point of common coupling, it will be connected through the grid. So whenever we require excess energy, we can take it from the grid. So this is regarding the microgrid. So now let us go for some challenges in the future grid. So the challenges in the future grid basically includes that we are having the complete rebuilding of the existing electrical system, and it will basically time consuming and expensive. Another concern in the smart grid is that the real-time pricing of the smart meter may negatively affect to the particular industries. That suppose in the hospital we cannot reduce the demand at a particular time when the cost is high. So that type of, you can say, consumers cannot take the advantage of this real-time pricing, and that will create the negative effect. So another challenge in the implementing of the smart grid is that the utilizing of the internet in the real-time grid data, which will increase the risk of privacy. Suppose we are having internet and somebody has hacked our meter or that digital thing, then it might happen, it can control whole electricity in the smart grid. So this type of problems or challenge is available in the future grid. So scenario of the electricity market, right now we are having few producers, less competition, regulated by the government, but in the future it will be in the terms of free market. Many producers like wind, solar, this type of energy sources can be utilized, and it will be less regulations. The future grid will be ultimately, it is the energy system with internet or internet of energy. Okay, so this is the way we can use the smartness in the grid, which can becomes the future in the grid system. So generally energy management is required in this, because one has said, that Billy Graham, that energy out of control is dangerous and it should be under the control. Then only it will be a powerful system. And one more thing, that energy cannot be created or destroyed. It can just changes the form. Okay, so this is the all the things that how the future grid will behave and how energy management can be utilized. So to do this, I have used some references. So these are the list of references, and thank you. So now, if you have any questions, then we can discuss, or you can mail me in my mail ID, which will be given by the Sheetal madam to you. And I hand over this session to Sheetal madam.
Okay, good morning, all of you.
Good
Any
morning, ma'am.
any query regarding that topic of a webinar? Any questions? Any question from participants?
No, ma'am.
If no question, then I'm concluding that session. Meet Pankti, Ria.
You can
Okay,
give my
then.
mail ID, and they can send their query to the mail ID. I will definitely try to answer.
Okay. So I will send madam's mail ID to you. Okay. If any query, they can directly contact with the madam. Okay. So I'm concluding the session. So on the behalf of Parul University, thank you, Dr. Dharmishta Vishwakarma madam, for sharing your valuable time and your knowledge in microgrid and smart grid. What is smart grid, advantages, disadvantages, and how to manage energy management in all these things. So thank you very much for your time, madam.
Thank you,
It was
madam.
nice session, and content is also very good. Thank you, madam.
Thank you so much for all the participants who have attended this webinar. Thank you so much, Sheetal madam, and all the Parul team who has invited me to and give me opportunity to deliver this type of talk for the students. And definitely, I expect this type of webinars will be available for the students in not in this area, in all other areas also. And I will try to help in any of the manner that required for the students. I can do in future. Okay? Thank you so much.
Okay, madam. Thank you. So we are concluding the session. Thank you, madam.
Thank you.